If you were to construct a perfectly sealed glass box, measuring exactly 1 cubic meter, and place it randomly anywhere in the observable universe, you would find it almost entirely vacant. Perhaps you would capture a single, solitary atom of hydrogen, a few stray photons from the cosmic microwave background. The universe is, at its foundational level, a freezing and profound desolation. Yet, gravity is the relentless architect of reality. Over 13.8 billion years, it has forcefully woven this thin, scattered dust into a glowing cosmic web. It is a sprawling, interconnected architecture of galaxies, superclusters, and invisible dark matter filaments. This web dictates where light gathers and where darkness is allowed to reign. We understand the basic mechanics of this web. Our most advanced simulations, running on supercomputers calculating the movements of trillions of particles, predict exactly how much empty space should organically exist between these glowing threads. The math is predictable, the physics are understood, but the mathematics just broke. Looking outward, in the direction of the constellation known as Boötes, sitting roughly 700 million light-years from our home planet, there is a structural anomaly that threatens to unravel our understanding of cosmic evolution. It is a spherical region of profound, impossible nothingness. According to the ironclad laws of cosmology, a region of this immense volume should contain at least 2,000 massive galaxies. Instead, we have found a staggering wasteland, a spherical desert measuring 330 million light-years across. It is a tear in the fabric of the cosmos so incomprehensibly colossal that if our own Milky Way galaxy were placed dead in its center, the human race would not have even known that other galaxies existed until our optical technology reached the level of the late 1960s. We call it the Boötes Void. For decades, the scientific community assumed this gaping hole was simply a statistical error, a dark trick played by interstellar dust, or a limitation of our early observatories. But as we point our most advanced instruments toward this abyss, including the National Aeronautics and Space Administration's James Webb Space Telescope, the reality is proving to be infinitely more unsettling. This void is not an error. It is a real, physical entity. And what is worse, we just realized it is not completely empty. Something is hiding inside the dark. A handful of isolated, lonely systems drifting in an ocean of absolute silence, raising questions that astrophysicists are struggling to answer. Are these stray galaxies the forgotten survivors of a cosmic cataclysm, or are they the final, flickering remnants of a region that was actively erased by an unknown force? If you seek the truth in the dark, subscribe and join us on this journey. When you step outside on a clear, moonless night and look up at the sky, your biological intuition lies to you. Your primate brain, evolved over millions of years to recognize immediate patterns in the local environment of a terrestrial planet, interprets the starry canopy as a uniform, even distribution of light, a painted ceiling of scattered, random diamonds. For thousands of years, this optical illusion dictated the absolute boundaries of human philosophy. We assumed the cosmos was smooth. Even Albert Einstein, when he formulated his general theory of relativity in the early 20th century, held fast to a foundational concept known as the cosmological principle. This principle states that, on a large enough scale, the universe is both homogeneous and isotropic. It looks the same in every direction, and matter is distributed evenly throughout the endless dark. It is a profoundly comforting thought. It implies an orderly, predictable, and democratic universe where no single location is unique and no region is inherently more chaotic than another. To understand why this intuition is fatally flawed, we must look at how astrophysicists actually measure the abyss. You cannot use a physical tape measure to gauge the distance to a galaxy millions of light years away. For generations, our maps of the sky were completely flat. We could see the coordinates of a star on a two-dimensional plane, but we had absolutely no concept of depth. A tiny, dim star could be a small object relatively close to Earth, or it could be a colossal, raging inferno burning millions of light years in the distance. We were completely blind to the third dimension of the universe. To pierce this two-dimensional veil, you must decode the light itself. When a distant galaxy emits a photon of light, that photon must travel across the vast, expanding fabric of space-time to reach the lens of a human telescope. But space is not static. It is stretching. As the space between us and the distant galaxy expands, it literally stretches the light waves traveling through it, pulling them apart and pushing them toward the red end of the electromagnetic spectrum. We call this phenomenon redshift. It is the cosmic equivalent of listening to a train siren as it speeds past you. As the train approaches, the sound waves are compressed, creating a higher pitch. As it violently speeds away, the sound waves are stretched, dropping to a lower, deeper pitch. Light behaves in the exact same manner. By running the faint light of a distant galaxy through a spectrometer, a device that breaks light down into its component colors like a glass prism, scientists can measure exactly how much the light waves have been stretched. The greater the redshift, the farther away the galaxy is, and the faster it is receding from us in the expanding void. This technique, pioneered in the 1920s, transformed astronomy from a science of flat photographs into a three-dimensional cartography of the cosmos. But mapping the deep universe requires agonizing, brutal patience. It requires pointing massive, ground-based optical telescopes at tiny, seemingly empty patches of the night sky, capturing ancient photons one by one over hundreds of frozen hours inside dark observatories. For decades, our maps were frustratingly shallow. We only saw our immediate cosmic neighborhood, and it looked exactly as Einstein predicted: smooth, random, predictable. It was not until the late 1970s and early 1980s that technology finally allowed us to cast our gaze deeper into the abyss. The advent of charge-coupled devices and automated spectroscopy allowed pioneering astronomers to begin conducting massive redshift surveys. They embarked on a monumental task to plot the precise three-dimensional coordinates of thousands of distant galaxies, effectively slicing the universe open to see its cross-section. They expected to find the cosmological principle validated. They expected to find a random, even scattering of galactic dust spreading out into infinity. What they found instead fundamentally shattered our understanding of reality. The universe is not a uniform ocean. It is a macro-scale, biological-looking web. When the first three-dimensional maps emerged from the computing mainframes of the 1980s, the data revealed that galaxies are not scattered randomly. They are violently clustered together, driven by the relentless, invisible hand of gravity. Matter over billions of years has drained out of vast regions of space, collapsing into colossal, glowing rivers of galaxies called filaments. These filaments stretch for hundreds of millions of light-years. Where these monumental threads intersect, they form superclusters, massive, chaotic metropolises of light, gas, and dark matter containing tens of thousands of galaxies bound together in a perpetual, inescapable gravitational dance. But this architecture creates a terrifying logical paradox. If matter is actively pulling itself together into these glowing threads, it must be permanently abandoning the spaces in between. Imagine a quiet, sprawling, modern city in the dead of night. If you look down from a high-altitude aircraft, you see veins of bright yellow light tracing the major highways, pooling into blinding hubs of energy at the city centers. But between those illuminated highways, there are vast, pitch-black expanses, the empty farmlands, the uninhabited deserts. The cosmos functions on a chillingly similar architecture. The glowing highways are the galactic filaments. The dark expanses are what astrophysicists officially call voids. Voids are not a mistake of the cosmos. They are a strict mathematical consequence of gravity. To understand how a void is born, we must look back to the very early universe, roughly 380,000 years after the Big Bang. At this time, the universe was filled with a searing, dense fog of hydrogen and helium plasma, and it was distributed almost perfectly evenly. Almost. There were microscopic quantum fluctuations in the density of this plasma, tiny, invisible regions where matter was just a fraction of a percent denser than the surrounding space. Over millions of years, as the universe expanded and cooled, these microscopic imbalances became the absolute masters of cosmic destiny. Gravity is an unrelenting positive feedback loop. The slightly denser regions of space had slightly more gravitational pull, allowing them to drag in stray matter from their immediates. As they grew more massive, their gravitational grip strengthened exponentially, accelerating the theft of material from the less dense regions. It is a cosmic-scale game of tug-of-war, where the mathematically strong relentlessly consume the weak. The regions that lost this gravitational battle were slowly, inevitably, emptied out. As the universe expanded, these desolate regions stretched, becoming the deep, silent voids we see in our telescopic surveys today. A standard cosmic void is vast, but it operates within the strict, calculated boundaries of physics. A typical void spans roughly 30 million to 100 million light-years across. They are immensely isolating spaces, containing only a sparse smattering of rogue dwarf galaxies, but they make perfect mathematical sense. Our supercomputer simulations, which modeled the precise gravitational dynamics of dark matter over 13.8 billion years, perfectly predict the existence, the frequency, and the maximum size of these standard voids. Physics dictates a strict speed limit to how fast matter can move through the vacuum of space, and consequently, how quickly a region of space can be naturally evacuated by gravity. Because the universe has only existed for 13.8 billion years, there simply has not been enough time for the slow, mechanical pull of gravity to clear out a space larger than a certain, rigid, mathematical threshold. Matter moves slowly. The expansion of the universe is a competing force, trying to push things apart, while gravity tries to pull them together. This delicate balance means that a void can only grow so large before the universe simply runs out of time on the cosmic clock. We built our entire modern cosmological model on this threshold. The equations worked flawlessly. The supercomputer simulations matched the raw telescopic data gathered by observatories around the globe. The universe, while terrifyingly vast and structured like a dark, glowing web, was behaving exactly as our physical equations demanded. Astrophysicists were satisfied. Our mathematical models gave us a comforting illusion of total control. We believed we had mapped the absolute boundaries of nothingness, and that the architecture of the dark was fully understood. In the autumn of 1981, the illusion of our perfect, predictable universe was quietly dismantled inside a freezing observatory on a mountaintop in Arizona. A team of 4 astrophysicists, Robert Kirshner, Augustus Oemler, Paul Schechter, and Stephen Shectman, were conducting what was supposed to be a routine redshift survey at the Kitt Peak National Observatory. They were not looking for anomalies. They were simply acting as cosmic cartographers, pointing a massive 2.1-meter optical telescope toward the constellation of Boötes to map the three-dimensional coordinates of distant galaxies. To understand the agonizing precision of this work, you must understand how a photon of light ends its journey. Imagine a single particle of light born in the thermonuclear furnace of a distant star. It travels for 700 million years across the freezing, hostile vacuum of deep space. It dodges the gravitational pull of black holes, passes through invisible clouds of intergalactic gas, and finally, after a relentless journey across the abyss, it crashes into the glass mirror of a human telescope on a tiny, wet rock orbiting an unremarkable star. The scientists capture that ancient photon, feed it through a spectrometer, and measure its redshift to determine exactly how far away its home galaxy is located. The team at Kitt Peak was measuring 3 very specific, small cones of the night sky within the Boötes region. They were painstakingly gathering data, expecting to see a standard, predictable distribution of galaxies stretching outward into the deep universe. As they plotted the distances of the galaxies they found, the data began to form a shape, but there was a catastrophic flaw in the numbers. Between a redshift measurement of 0.04 and 0.06, representing a physical distance of roughly 500 million to 700 million light-years away from Earth, the galaxies simply vanished. At first, they assumed it was an equipment failure, a mechanical ghost in the spectrometer, or perhaps a thick cloud of obscuring interstellar dust in our own Milky Way galaxy was blocking the light from the Boötes region, acting like a cosmic blindfold. But as they cross-referenced their data, checking and rechecking the optical plates, the terrifying reality began to solidify. The instruments were functioning perfectly. There was no dust cloud. The galaxies were not obscured. They were simply gone. They had discovered a spherical volume of nothingness so colossal that it defied every existing model of physics. When they published their findings in a paper titled "A Million Cubic Megaparsecs of Nothing," the scientific community was thrust into a state of profound disorientation. The Boötes Void had been dragged from the shadows and placed onto the map. To comprehend the true, terrifying scale of the Boötes Void, we must abandon our terrestrial understanding of distance. Human brains are not wired to process numbers of this magnitude, so we must rely on cold, unforgiving analogies. The void is roughly spherical, and it measures 330 million light-years in diameter. If you were to take our entire Milky Way galaxy, an unfathomably massive spiral containing roughly 400 billion individual stars, and place it side by side in a straight line, you would have to line up more than 3,000 Milky Way galaxies just to bridge the gap from one side of the Boötes Void to the other. It is a volume of space so devastatingly vast that it accounts for nearly 0.27% of the entire observable universe. This may sound like a fraction, but in the context of infinity, it is a structural impossibility. Based on the average density of the cosmic web, a region of space this massive should contain a minimum of 2,000 glowing, fully formed galaxies. It should be a bustling, chaotic metropolis of dark matter and ancient starlight. By the late 1980s, after years of frantically scanning the dark with the most powerful instruments on Earth, astronomers finally found something inside the void, but it did not bring comfort. They found 8 solitary galaxies. By the late 1990s, that number crawled up to roughly 60 isolated galaxies, drifting in a volume of space that should contain thousands. They are scattered so incredibly far apart that they are fundamentally disconnected from the rest of the universe. And this isolation leads to one of the most chilling philosophical thought experiments in modern astrophysics. Imagine, for a moment, the sky of a hypothetical planet orbiting a star inside one of those 60 lonely galaxies, locked deep within the dead center of the Boötes Void. When a human being stands on Earth and looks up at the night sky, we are looking through the dusty, glowing arms of our own Milky Way. But even with a basic backyard telescope, we can easily see beyond our borders. We can see the Andromeda galaxy sitting 2.5 million light-years away, glowing like a faint smudge in the dark. Our proximity to other galaxies in our local supercluster has heavily dictated our cultural and scientific evolution. It proved to us that we are part of a larger, populated universe. But for a biological civilization born in the center of the Boötes Void, the night sky would be a psychological prison. They would look up and see the stars of their own galaxy, just as we do. But beyond the edge of their galaxy, there would be absolutely nothing, an infinite, suffocating wall of total blackness. Because the nearest neighboring galaxy within the void could be tens of millions of light-years away, their faint light would be entirely invisible to the naked eye and completely undetectable by early optical instruments. If this hypothetical civilization evolved and eventually built grand glass lens telescopes akin to those used by human astronomers in the 1800s, they would aim them at the dark and find nothing. They would refine their lenses, build larger observatories on their highest mountains, push their optical engineering to the absolute limit, and still the dark would remain empty. Their philosophers and religious leaders would construct entire worldviews based on the absolute certainty that their single, solitary galaxy was the only object in the entire universe. They would have no concept of a cosmic web, no concept of clusters, just a lonely island of light surrounded by an endless, frozen ocean of absolute zero. It would take centuries of technological progression for them to realize the terrifying truth. It would not be until their civilization developed highly advanced radio telescopes, equivalent to the technology humans achieved in the late 1960s, that they would finally be able to detect the faint, invisible electromagnetic radiation from galaxies outside the void. Imagine the cultural shock of that specific generation. For thousands of years, you believe your island is the entire universe. And then, on a random Tuesday, a massive radio dish pulls in a signal that proves you are sitting at the bottom of a 330 million light-year deep well of nothingness, and that the rest of the universe is glowing vibrantly, impossibly far out of reach. This extreme isolation is not just a philosophical nightmare. It is a physical anomaly that violently contradicts the rules of the cosmic web. Remember the mechanics of gravity we discussed earlier. Standard voids are formed because slightly denser regions of space slowly pull matter away from less dense regions. It is a slow, mechanical process constrained by the speed limit of the universe and the finite age of 13.8 billion years. Our supercomputer models simulating the precise movement of dark matter, calculate that a standard, naturally occurring void cannot possibly grow larger than 100 million light-years across. There simply has not been enough time since the Big Bang for gravity to clear out a space any larger than that. It would be like trying to drain the Pacific Ocean with a single plastic bucket in a matter of hours. The math simply does not permit it. Yet, the Boötes Void exists, and it is more than 3 times larger than the absolute maximum size allowed by the laws of physics. It is a spherical anomaly, standing in direct defiance of gravitational theory. Its borders are incredibly sharp, almost perfectly spherical, as if a colossal visible bubble was inflated inside the cosmic web, pushing the glowing filaments of galaxies outward to form a hard, dense shell around the emptiness. When astronomers look at the very edges of the void, they see these dense walls of galaxies, packed tightly together like debris pushed aside by a snowplow. But inside the perimeter, the vacuum reigns supreme. The few dozen galaxies that manage to survive inside are highly unusual. They are forming new stars at a strange, accelerated rate, burning bright and blue in the dark, feeding on the isolated, undisturbed pockets of primordial gas that were left behind. They are like the last flickering campfires in an abandoned continent. As the 1990s gave way to the 2000s, and our technological capacity to map the universe grew exponentially with the launch of orbiting observatories, the scientific community scrambled to explain this impossible architecture. If the standard model of gravitational pull could not create a void of this magnitude, then some other mechanism must be responsible, some hidden, mechanical gear turning behind the curtain of reality. Theoretical physicists began to propose terrifying solutions. Some suggested that the void was not a single entity, but an unnatural convergence. Others pointed to the dark, invisible forces that we cannot measure with optical glass. The deeper we looked into the black, the more we realized that the Boötes anomaly was not just a gap in the map. It was a physical symptom of a universe that was behaving in ways we could not predict, and perhaps could not control. The equations were broken, and the dark was spreading. When a physical observation fundamentally contradicts a mathematical absolute, the scientific community is forced into a state of agonizing friction. We possess a model of the universe known as the Standard Model of Cosmology. It is a rigid, mathematical framework that relies on the precise balance of visible matter, and dark energy to explain how the universe grew from a microscopic singularity into the sprawling cosmic web we observe today. This model works brilliantly to explain almost everything, but it cannot explain the Boötes Void. To understand the sheer panic this anomaly induces in the minds of theoretical physicists, we must dissect the kinetic mathematics of the void. We must look at the strict speed limits of the universe. Matter is heavy, and the vacuum of space is a frictionless but unyielding environment. Even in the most violent gravitational environments, entire galaxies do not move quickly relative to the vastness of the cosmos. An average galaxy drifts through the cosmic web at a speed of roughly 600 kilometers per second. To a human mind, traveling 600 kilometers every single second seems like an incomprehensible velocity, but on the scale of deep space, it is nothing more than a slow, glacial crawl. If we apply this maximum speed limit to the Boötes Void, the paradox becomes terrifyingly clear. Imagine a single galaxy, positioned exactly at the dead center of where the void is today, immediately after the birth of the universe 13.8 billion years ago. For that galaxy to reach the outer edge of the void, to be pushed or pulled out of that region of space to create the emptiness we see. It would have to travel a straight-line distance of 165 million light-years, even traveling at a blistering maximum speed, propelled by the strongest theoretical gravitational currents. It would take that single galaxy billions upon billions of years to cross that distance. When physicists run the exact calculations through supercomputers, the result is chilling. To naturally clear out a spherical region of space measuring 330 million light-years across, the process would take significantly longer than the current age of the universe. The math simply does not fit reality. The universe has not existed long enough for gravity to dig a hole. This massive Boötes Void should not be physically possible. Faced with this immovable barrier, astrophysicists desperately began to construct alternative theories. If a single, slow process of gravitational pull could not explain it, perhaps a violent, compounding process could. They proposed what is now known informally as the soap bubble theory. Imagine a sink filled with water and liquid soap. If you agitate the water, thousands of tiny, individual bubbles form. As time passes, these smaller bubbles begin to press against one another. The thin films of water separating them eventually break, and two small bubbles merge into one larger bubble. This process continues, cascading outward, until a massive, singular dome of air dominates the surface of the sink. Physicists theorized that the Boötes Void did not begin as one colossal empty space. Instead, in the primordial dark of the early universe, there were dozens of smaller, perfectly standard voids. These smaller voids, measuring perhaps 20 or 30 million light-years across, were entirely permitted by the laws of physics. Over billions of years, as these smaller voids expanded, the thin walls of galaxies separating them were stretched to their absolute breaking point. Eventually, those cosmic walls collapsed. The smaller voids crashed into one another, violently merging to create the staggering 330 million light-year abyss we see today. It is an elegant theory. It circumvents the cosmic speed limit by allowing multiple empty regions to grow simultaneously and combine. But when we aim our telescopes back into the dark to verify this hypothesis, the universe refuses to cooperate. If the Boötes Void was truly the result of dozens of smaller voids merging violently together, the resulting empty space should be messy. It should be asymmetrical. We should see jagged, irregular borders where the smaller bubbles collided. We should see massive, stranded islands of galactic debris floating in the center. The broken remnants of the walls that used to separate the smaller voids. But we do not see debris, and we do not see jagged borders. The Boötes Void is alarmingly pristine. Its outer walls, composed of thousands of tightly packed galaxies, are incredibly smooth and nearly perfectly spherical. It does not look like a chaotic collision of smaller bubbles. It looks as though a single, monolithic force simply erased everything inside a perfectly measured radius. This lack of internal debris brings us to an even darker scientific impasse. To understand the void, we must abandon visible light and look at the invisible scaffolding of reality. We must talk about dark matter. Everything we can see, every burning star, every swirling nebula, every massive black hole, and every human being, is made of standard, baryonic matter. But baryonic matter only makes up roughly 5% of the entire universe. The vast majority of the gravitational mass in the cosmos belongs to dark matter. It is an invisible, untouchable substance that does not emit, absorb, or reflect light. We only know it exists because we can see its immense gravity bending light. and holding entire galaxies together. Dark matter is the true architect of the cosmic web. Where dark matter gathers, its gravity pulls in regular matter, igniting the fires of star formation. Where dark matter is absent, regular matter simply drifts away, leaving an empty void. Therefore, if the Boötes Void is missing its regular galaxies, it must also be missing its dark matter. It is a 330 million light-year gap in the very foundation of the universe. This leads physicists to a deeply unsettling question. What if the Boötes Void was not formed over billions of years? What if it was born completely broken? To grasp this, we must look at the first fractions of a second after the Big Bang. The universe was entirely microscopic, governed not by the classical laws of gravity, but by the chaotic, unpredictable laws of quantum mechanics. In the quantum realm, energy is never perfectly smooth. It fluctuates constantly, boiling and bubbling with minute variations in density. When the universe underwent an event known as cosmic inflation, a period where space-time itself expanded faster than the speed of light, stretching the microscopic universe into macroscopic reality, those tiny quantum fluctuations were frozen and magnified. A microscopic area that was slightly denser became a region with slightly more dark matter. A microscopic area that was slightly emptier became a region with slightly less dark matter. Some theoretical physicists now argue that the Boötes Void is the ultimate quantum scar. They suggest that during the very first moments of creation, a massive, localized failure occurred in the distribution of dark matter. It was a mathematical anomaly from the very beginning, a patch of the universe that was simply forgotten during the initial distribution of mass. As the universe expanded, this initial flaw was stretched into the colossal abyss we observe today. If this theory is correct, it means the void is not an active process of galaxies drifting apart. It means the void is an intrinsic, permanent defect in the fabric of space-time itself. A haunting reminder that the mechanisms of the Big Bang were not perfectly uniform. Yet even this primordial defect theory struggles to explain the behavior of the few things that do exist inside the void. Remember the handful of solitary galaxies, roughly 60 of them, that manage to survive deep within the dark. If the void is a primordial wasteland, these galaxies should be scattered randomly, aimlessly drifting, without any internal structure. But when astronomers mapped the precise coordinates of these isolated systems, they discovered another structural anomaly that sent shockwaves through the astrophysics community. The galaxies inside the Boötes Void are not scattered randomly. They form a perfectly straight line. They are arranged in a tubular formation, a single glowing string of galaxies cutting straight through the dead center of the darkness. Scientists refer to this phenomenon as a tubular structure. It is as if a single, microscopic filament of dark matter managed to survive the evacuation of the void, holding onto a tiny string of matter while everything around it was stripped away. Imagine a massive, empty cavern stretching for miles underground. In the absolute center of this pitch-black cavern, a single, thin wire hangs suspended from the ceiling to the floor, studded with microscopic, glowing LED lights. That is what the interior of the Boötes Void looks like. It is a structure so delicate, so incredibly fragile against the overwhelming scale of the emptiness, that its very existence defies our understanding of cosmic erosion. How did this single string of galaxies survive? Why didn't the surrounding vacuum tear it apart billions of years ago? The existence of this tubular structure introduces the most terrifying player in modern astrophysics, a force so dominant and so poorly understood that it threatens to tear the entire universe apart. We must now speak of dark energy. For decades, scientists believed that the gravitational pull of all the matter in the universe would eventually slow down the expansion of space. They believed the universe was acting like a thrown baseball, moving upward, fighting gravity, inevitably slowing down before falling back in on itself. But in 1998, two independent teams of astronomers measuring distant supernova made a discovery that shattered physics. The expansion of the universe is not slowing down. It is accelerating. Galaxies are flying away from each other, faster and faster every single day. The universe is acting like a thrown baseball that suddenly ignites a rocket engine in midair, accelerating violently into the sky. We call the invisible force driving this acceleration dark energy. And unlike gravity, which is tied to the presence of matter, dark energy is tied to the vacuum of space itself. It is an inherent property of nothingness. The more empty space there is, the more dark energy exists to push outward. This brings us to a terrifying realization about the true nature of cosmic voids. We used to view voids as passive, dead regions, empty graves where matter used to be. But the discovery of dark energy forces us to view voids as something entirely different. They are active, hostile engines of expansion, because standard regions of the universe, like our own local supercluster, are packed with galaxies and dark matter. The inward pull of gravity is incredibly strong. This local gravity is powerful enough to resist the outward push of dark energy. Our local space remains tightly bound together, but inside a massive void, there is absolutely no gravity to fight back. Inside the Boötes Void, there is no dark matter. There are no massive galactic clusters to anchor the space. It is an environment completely and entirely dominated by dark energy. Because there is no resistance, the space inside the Boötes Void is expanding significantly faster than the space outside of it. The void is literally pushing outward. It is generating a localized, repulsive force, a massive pressure front of pure dark energy that is actively crushing the glowing walls of the cosmic web surrounding it. This explains why the borders of the Boötes Void are so incredibly sharp and smooth. The void is not just empty, it is inflating like a high-pressure balloon inside a confined space, physically ramming the surrounding galaxies together, compressing them into dense, blinding walls of light. It is acting as a macroscopic wedge, driving the universe apart from the inside. This realization completely changes the paradigm of the mystery. We are no longer just looking at a hole where matter is missing. We are looking at a monstrous, localized engine of cosmic acceleration, and the Boötes Void is the largest, most powerful engine we have ever discovered. This localized acceleration creates a devastating problem for cosmologists trying to measure the fundamental constants of nature. One of the most important numbers in all of physics is the Hubble constant. It is the exact rate at which the universe is expanding. To determine this number, astronomers measure the distance and speed of galaxies millions of light-years away. But if we are observing galaxies that are being pushed by the immense artificial pressure of a supervoid, our measurements become deeply corrupted. The void creates a localized wind of dark energy, blowing galaxies outward faster than the normal background expansion of the universe. If an astronomer fails to account for the repulsive force of a nearby void, their entire mathematical model of the universe becomes fatally flawed. This tension in the data is currently tearing the astronomical community apart. When we measure the expansion of the early universe using the ancient light of the cosmic microwave background, we get one specific number for the Hubble constant. But when we measure the local, modern universe using supernova and nearby galaxies, we get a significantly faster, entirely different number. The two numbers do not match. The math is broken, and many leading physicists now believe that massive, unseen voids, perhaps voids we are currently sitting perfectly inside of without even realizing it, are the invisible culprits skewing our data and blinding us to the true mechanical reality of the cosmos. We are faced with an insurmountable barrier. We cannot travel to the Boötes Void. We cannot send probes into its dark interior to measure the vacuum pressure. We are locked on a tiny rock, forced to look through a glass lens at a 330 million light-year monster that is actively rewriting the laws of physics. And the deeper we analyze the data, the more we realize that this void is not just an astronomical curiosity, it is a weapon of pure expansion. The Boötes Void is a weapon of pure expansion, but it is not unique in its objective. It is merely the largest, most aggressive vanguard of an unavoidable cosmic fate. To understand the hidden consequences of this supervoid, we must recognize that the dark is not a passive backdrop. The empty spaces in the universe are actively hostile to the existence of matter, and they are currently winning the ultimate war of attrition. We imagine the cosmic web, the glowing filaments of galaxies, dark matter, and superstars as a permanent architectural structure, but it is incredibly fragile. The filaments are held together by gravity. Gravity is a force that weakens exponentially over immense distances. Dark energy, conversely, does not weaken. It is a constant, unrelenting pressure generated by the vacuum of space itself. As the voids between the filaments grow larger, they generate more dark energy. As they generate more dark energy, they push the filaments further and further apart. It is a fatal mathematical feedback loop. More empty space creates more repulsive force, which creates even more empty space. Eventually, the immense gravitational tension holding the cosmic web together will reach its absolute limit. The delicate, glowing threads connecting the superclusters will be stretched beyond their breaking point, and they will snap. Imagine a colossal, intricate spiderweb covered in morning dew, suspended between two massive trees. Now imagine those two trees are slowly, mechanically being pulled apart by an invisible winch. For a time, the silk of the web stretches. The individual droplets of water, representing galaxies, slide along the threads, grouping together in defensive clusters. But eventually, the structural integrity of the silk completely fails. The threads snap violently, recoiling into isolated, disconnected fragments. The grand design is permanently destroyed, leaving only scattered, lonely islands of matter adrift in the wind. This exact mechanical failure is the destiny of our universe. The Boötes Void is not just a geographical anomaly on a map. It is a terrifying window into the deep future. It is a localized preview of the ultimate end state of all reality. To fully grasp the horror of this consequence, we must look at the strict laws of thermodynamics and the absolute speed limit of physical information. Light travels at roughly 300,000 kilometers per second. It is the absolute fastest messenger in the universe. But the expansion of space, driven by the dark energy bubbling within massive voids, is not bound by this speed limit. Space itself can literally expand faster than the speed of light. When a region of space is pushed away from us at a speed exceeding the velocity of light, it crosses a terrifying mathematical boundary known as the cosmological event horizon. Once a galaxy crosses that threshold, its light can never, ever reach us again. Even if you waited for an infinite amount of time, the photons emitted by that galaxy would be fighting a losing battle, trying to swim upstream against a river of expanding space that is flowing faster than they can physically travel. Right now, as you listen to this, thousands of distant galaxies are quietly slipping over that horizon. They are being permanently erased from our observable universe by the relentless expansion of the voids. Every single second, the physical universe that we can see, measure, and interact with is becoming smaller and darker. Fast forward the cosmic clock by 100 billion years. The forces currently driving the Boötes Void will have replicated across the entire cosmos. The infinite voids will have merged, inflated, and consumed the entire architecture of the web. Our Milky Way galaxy will have collided and merged with the Andromeda galaxy, creating one massive, solitary elliptical island. But when the inhabitants of that future supergalaxy look up at the night sky, they will be greeted by an absolute, suffocating darkness. Every single other galaxy in the universe will have been pushed across the cosmological event horizon, the ancient light from the Big Bang, the cosmic microwave background that currently allows our scientists to measure the age and origin of reality, will have been stretched so severely by the expanding voids that its wavelength will be longer than the physical size of the universe itself. It will become fundamentally undetectable. Future astrophysicists, living 100 billion years from now, will have absolutely no observational evidence that the universe is actively expanding. They will have no evidence of the Big Bang. They will have no physical proof of the cosmic web, or dark matter, or other distant galaxies. When they build their massive glass lens telescopes and peer out into the black, they will see the exact same terrifying emptiness that the hypothetical civilization inside the Boötes Void sees today. They will scientifically deduce, using the most rigorous and flawless logic available to them, that their single, glowing island of stars is the entire universe, suspended in a static, infinite, and eternal vacuum. Their science will be mathematically perfect based on their available observations, and it will be completely, disastrously wrong. This is the most profound and unsettling consequence of the accelerating dark. The universe is not just physically pulling itself apart, it is actively, mechanically erasing the evidence of its own history. The window of time in which biological life can actually observe the cosmic web, measure the redshift of distant galaxies, and mathematically understand the true mechanics of the cosmos is incredibly, terrifyingly narrow. We happen to exist in a razor-thin sliver of cosmic time where the universe is cool enough to support complex chemistry, yet young enough that the grand architecture of reality has not yet been entirely ripped apart. We live in a deeply privileged era of observation. But this era is temporary. The Boötes Void proves that the natural, resting state of the cosmos is not light, or structure, or connection. The natural state of the cosmos is absolute, isolating emptiness. Let us look back closely at the void itself. Let us reconsider those 60 lonely galaxies trapped inside its 330 million light-year diameter. For decades, we viewed them as bizarre anomalies, as lucky, statistical survivors of a brutal, ancient gravitational war. But through the modern lens of our understanding of dark energy, their nature shifts into something far more tragic. They are not survivors. They are hostages. They are caught in a massive region of space where the expansion rate is significantly higher than the rest of the universe, because there is no immense gravitational anchor of a supercluster to hold them together. The localized dark energy within the Boötes Void is pushing those 60 individual galaxies apart at an incredibly violent, accelerated speed. They are experiencing the literal end of the universe billions of years ahead of schedule. While our Milky Way is still comfortably nestled within the gravitational safety of the massive Laniakea supercluster, surrounded by hundreds of thousands of neighboring galaxies, the residents of the Boötes Void are already plunging headfirst into the epoch known as the Big Freeze. The Big Freeze, or the ultimate heat death of the universe, is the inescapable conclusion of this extreme expansion. As voids grow and galaxies are pushed beyond the horizons of visibility, the raw materials required for star formation, the massive clouds of interstellar hydrogen and helium gas, are stretched too thin. Without sufficient gravitational pressure to condense this gas, the birth of new stars will simply cease entirely. Inside the 60 isolated galaxies of the Boötes Void, the stellar engines are burning through their strictly finite fuel. Because they are isolated in the absolute vacuum, they have no physical way to capture new gas from surrounding galactic filaments. They are closed thermodynamic systems, and in a closed system, entropy always, relentlessly wins. One by one, the massive, brilliant blue stars inside those trapped galaxies will exhaust their thermonuclear cores and detonate into supernovas, leaving behind dead, ultradense neutron stars or silent black holes. The smaller, longer-lived red dwarf stars will continue to burn dimly for trillions of years, glowing like dying embers in a cold fireplace. But eventually, even they will run out of fuel and fade into the black. When the absolute last star in the Boötes Void extinguishes, those 60 galaxies will become completely invisible. They will turn into massive, wandering graveyards of black dwarfs, cold planetary cores, and frozen asteroids adrift in a darkness so absolute that temperature itself ceases to have any practical meaning. The background temperature of the void will drop infinitely close to absolute zero. The fundamental atomic movement within matter will slow to a virtual halt, and as this localized thermodynamic death occurs, the outer walls of the void will continue to violently expand. The 330 million light-year diameter will become 400 million, then 1 billion. The Boötes Void is acting like a massive, necrotic tumor on the body of the universe. It is a region of dead, empty space that is actively consuming the healthy, structured tissue of the cosmic web around it. Every single piece of mathematical data we drag out of the dark points to this singular, chilling conclusion. The structured universe, the beautiful, glowing web of filaments and superclusters that we spend billions of dollars to photograph, is merely a temporary, transitional phase. It is the fleeting smoke left behind by the initial explosion of the Big Bang. And just like smoke in an empty room, it is slowly dissipating into the corners, destined to vanish entirely. We are forced to confront a reality where time itself is our greatest enemy. The longer we observe the Boötes Void, the more we realize that it is not a window into the past. It is not a fossil of the early universe. It is a terrifying, massive mirror reflecting our own inescapable future. It is the physical manifestation of the second law of thermodynamics, written across hundreds of millions of light-years. The cosmic expansion driven by dark energy ensures that every single coordinate in the universe will eventually look exactly like the deepest, most barren center of the Boötes region. The night sky will be wiped completely clean. The grand cosmic architecture will be dismantled, brick by invisible brick, until nothing remains but isolated, frozen remnants floating in a silent, eternally expanding ocean. We are a biological anomaly obsessed with our own permanence. We construct monumental observatories of glass and steel, and we write complex mathematical equations to convince ourselves that we hold some measure of control over the cosmos. We desperately want to believe that the light is the default state of reality. We map the glowing filaments of the cosmic web and we call it a structure, as if it were a permanent house built to last for eternity. But the Boötes Void stands as a colossal, silent monument to our own irrelevance. It proves that the universe does not share our preference for architecture. It has no preference for warmth or memory or biology. The vast, interconnected web of galaxies that we currently call home is nothing more than a temporary physical glitch, a fleeting spark of friction in a grand machine that is violently and mechanically winding down to absolute zero. When we point our most advanced optics into that 330 million light-year deep abyss, we are not just looking at a geographical region of empty space. We are looking at the fundamental, unvarnished truth of existence. The dark is not an invading force. The dark is the foundation. It was there before the first hydrogen atom formed, and it will remain in absolute silence long after the final supermassive black hole completely evaporates into nothingness. Our entire terrestrial history, every civilization, every technological breakthrough, every agonizing generation of human thought has taken place entirely within a fragile, temporary oasis of light. And this oasis is currently being actively eroded by the unseen, repulsive forces of the vacuum. We are not the masters of our domain. We are simply passengers trapped in a slow, inescapable cosmic eviction. We spend our brief lifespans searching for meaning in the arrangement of the stars, desperately trying to matter on a universal scale. But the void offers a deeply sobering counter-argument. Meaning is a localized, biological construct. It requires a living observer. When the void finally pushes the last of the galaxies over the cosmological horizon, and the final biological observer is permanently extinguished, the very concepts of time, distance, and history will lose all physical significance. The universe will simply return to its perfect, unbroken symmetry of absolute nothingness, a state of complete and utter equilibrium. The ultimate fate of our reality is not a violent, cinematic explosion. It is not a dramatic collapse. It is a slow, methodical fade to black. The gravitational tension will fail. The glowing filaments of the web will snap. The isolated galaxies will drift across the event horizon, severing all contact with one another. The fundamental particles of matter will eventually decay, and the expanding supervoids will endlessly merge, until the entirety of the cosmos is completely indistinguishable from the suffocating emptiness of the Boötes anomaly. There is no grand, underlying purpose to this mechanical dissolution. The universe is not punishing us, nor is it protecting us. It is simply following the cold, unyielding laws of thermodynamics. It is systematically erasing itself, leaving absolutely no physical evidence that the light ever existed. The next time you step outside on a clear night and look up at the scattered, burning diamonds of the sky, do not let your intuition deceive you. Do not take artificial comfort in the painted ceiling of light. Look past the familiar stars. Look deeply into the pitch-black spaces that lie between them, because that silence is not empty. It is active, it is expanding, and it is waiting.